All right. So unit two, it's like it says unit two at the top, right?
Yeah, scatter plots and regression.
Scatter plots regression. So number one, describe the association between the variables. Looks like it's strong positive. Something like that would be good. Number two says draw a line of best fit for the data. Well, it's drawing a line of best fit. So these are all the things we're doing. So, and then predict the miles per gallon at 30. So 30, gosh, this graph is horrible. Where's 30? 30. So 30 is like here. We follow this up to the line. Looks like 25 is the answer. I'm sorry. Why am I reviewing? Not sure why I'm reviewing. Quite not sure why I'm the only one that's reviewing. I'm not the one who's taking the test next week. Why am I the only one reviewing? Still not sure why I'm reviewing. I didn't know I was reviewing.
Honestly, I didn't really know.
I don't know why you're reviewing anyhow, pal.
Well, I
All right, so we're on the scatter plot regression. I'm down to number 4 now. Oh.
Good morning, Cherry Creek High School. I apologize for this interruption, but I have some very exciting news. We just recently learned that our own Sharon Webb, who is the office manager at Cherry Creek High School, was named an all-star for the Cherry Creek School District. There are over 5,000 classified employees in this district, and only 18 were selected for this honor. And essentially, it's for classified employees who go above and beyond the call of duty. And Sharon has done that throughout her whole career, but especially this year as we have a new operating system. So please join me in congratulating Sharon Webb as an all-star for the Cherry Creek School District.
Should we call her? We can call her.
Yeah.
That would be funny. Unfortunately, it doesn't just go to her, so someone else would pick up. All right, number 4, the correlation. I thought they were going to say school's canceled, go home. You can't lead off some exciting news when it's snowing out. It's like,
Yeah, exactly.
like half of you already have the auto start on your car. You started your car already. Yeah. All right, correlation between homework and grades. The test grades is 0.56. So there's moderate positive linear relationship. Okay.
Moderate positive.
Yeah, well, it's positive because it's positive, and then moderate or cruddy or
So the
somewhat okay or
so the closer is -1 or 1 or more,
the better.
the better it is.
Yeah. Number 5 now on Unit 2 scatter plot regression. You what? Number 5, Unit 2 scatter plot regression.
Read the oh yeah, it's like my
Yeah, someone came in.
I literally on the board.
Anyone else come?
Like, I don't care for any of that. I just think that.
All right. Number 5, there's a negative association between vegetable consumption and cholesterol. So what you could say, meaning as vegetable consumption goes up, cholesterol levels tend to go down. Correlation between price and quality of cars is 0. There's no linear relationship between price and quality of cars. I don't know. I've definitely had some inexpensive cars that didn't work all that well. All right, then I'm on the next page. We collect data to study the relationships between time spent watching TV per week in hours and diastolic blood pressure, BP. The resulting regression equation is, actually the equation they have written is wrong. So the equation should have been predicted. So BP equals 0.625 TV, hours of TV, plus 78.75. Now, I have a question for you.
It says,
Yeah, they made a mistake on it. So we flip-flopped it. So I changed the equation.
okay, wait,
The original on the review was incorrect, so I changed it. So predicted it should be BP. Yeah. So I have a question. So when I do cardio, I usually bust out on YouTube and I'm watching like cops. Then I act like I'm the bad guy and the cops are chasing me. So I'm watching TV while I'm doing cardio. That's kind of a. Is it because I'm watching the TV that my beats per minute are going up, or is it because I'm exercising?
or is it because you're being chased by animals?
Yeah. Well, it's kind of fun. All right. Let's see. So again, they switched this. They changed the equation to this because it was incorrectly done. So we're going to go based off that. So if someone watches 8 hours of TV, you would just have to go 0.625 times 8 plus 78.75. Now realize on the test, because they claim we don't have to use a calculator on it, this would be the answer they would give. If you actually worked it out, you'd come out to 83.75. But that'd be blood pressure. Do we trust this regression model to make accurate predictions? We don't really know if we can trust this or not because we haven't been given any R value. Okay. Explain why we should not use this model to predict the number of hours of TV from someone with blood pressure of 92. Because that would be, you can't make a prediction on an explanatory variable. So you can't plug a Y value in to make a prediction on the X value. It's the X value to do the Y value. So on your equation, like if you have your line of best fit, say like is this, you can find an X value and come up and over and find a Y value. So this works to do this. It doesn't work going backwards.
So you can't make a prediction with a Y value, but you can make a prediction with an X value?
Statistically speaking, yes. Other times that you can't make those is if it is outside your data set. It would be extrapolation. Calculate the residual. For me, Chris, who watched 6 hours of TV, well, I don't know where this data is coming from. Did it?
Did you make it equal 88?
Oh, okay. So number 10 is done this way. So they're saying that this person has 88 as their thing. So they're going to plug the 6 into the equation. That's 0.625. Sorry about that. Times 8 plus 78.75. Do what? Oh, you guys are the best. So that means this is going to give me 82.5. So it's going to be, this is what I found. This is what our linear model should show. So you're going to have 88 minus 82.5. So looks like that was an over prediction. No, so my observed of my patient, this person, Chris, I hope they weren't referring to me. Yeah.
Your blood pressure is 88.
No, my blood pressure's pretty low. No, it's not my blood sugar.
Oh, yeah.
All right, let's see. For Russell, the residual value is positive. Explain what this means in the context. Okay. It went from Chris to Russell.
Russell, your middle name?
No, Robert's my middle name. All right, so I guess this was an over prediction. I don't know why we switched names. And then we know whether this line is a good fit for data, what information we need. We need the residual plot, or we just need the R value. Explain the meaning of the slope in the context of this question. So again, this is our slope here. So for each additional hour of TV, the blood pressure is predicted to rise by 0.65 hours. Oh, wait. 12. Residual plot or just the R value. The meaning of the slope of the context. So for each additional hour of TV, the blood pressure is predicted to rise by 0.625. Oh, shoot. And then y-intercept prediction is 0 hours of TV watching predicts a blood pressure of 78.75. And I'm almost done with this unit. A correlation of 0. So number 15. If we had a R value of about 0, that's just all over the place. Correlation of -1, which is 16, would be a negative slope. And consider scatter plot below. Look at the label outliers. Is this an outlier in terms of height, in terms of foot, or in terms of regression? It's height and regression, because that's what it's given in. And describe the outliers on the correlation. If you looked at an outlier, the correlation it would lower the correlation. The regression line rotates the regression line, making it. So if I had my data like this and I have this outlier down here, it's going to move our line of best fit down. So it's going to make it more closer to horizontal, not exactly horizontal.
Can you explain what is the height of the
Oh, look at the label. So look at so 17A you said, right?
Yeah.
Look at the point labeled outlier, which is way outside.
Yeah.
Is this an outlier in terms of height, in terms of foot, or in terms of regression? It's height because it's way outside on the X. It's outside of our data on the X. It's not outside of our vertical data. And then it's outside of what our regression equation would be. So like if our regression equation is here, it's down here. Okay. All right. That's all I have for today. Good. We'll do sum of chapter 3 on, which is supposed to be unit 4, but we mislabeled it. Good enough? All right.